Hey everybody, this is Larry. This is me doing week 5 of the premium weekly challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. 776 split BST, and we haven't done it today, so yay, new problem. Let's take a look. Given the root of a binary search tree, a BST, and an integer target, split the tree into two subtrees where the first subtree has all the nodes that are all smaller or equal to, and the second subtree has all nodes that are greater than the target value. It's not necessarily the case that the tree contains a node of the value target. Okay. Okay. I'm trying to think about how to handle this in a good way. I think I think the least destructive way. There's only 50 nodes, so maybe we could do something lazy. But I think the least destructive way, that in theory, but I don't know if I'm going to do it, is to binary search for the number, and then split, and then kind of do a recursive thing to kind of find nodes, and then with the extra nodes, you just put it back onto the other number, right, or the other side of the tree. But I don't know. Oh wait, maybe that is what they want. Additionally, most of the structure of the original tree should remain. Okay, so we should not create new trees, I suppose. Because I think the easy way, which I'm tempted, is just to do a depth first search, create a new tree, and be done with it. I'm trying to. I mean, it's not that hard to understand and even conceptually do, but I think this is one thing about having experience and kind of and being jaded a little bit with all these type of problems, is that you recognize how hard a lot of the edge cases could be, and I'm just thinking through in my head like how to implement in a way such that the edge cases don't come up as much as I hope they do, or I don't, or whatever, they don't come up, right? Yeah, and it's kind of scary to think. Okay. Formally, for any child C with the parent P in the original tree, if they're both in the same subtree, then node should C if the. Okay, so. Okay. It's just a lot of if statements. I think that's the thing, right? It's not that, like, I don't think arithmetically is super interesting, but maybe it is in terms of implementation and kind of handling the case. How do you want to think about this? So we definitely want to find the root of what we want, right? So okay, so the original tree would depend on the root dot value, right? So if root dot value, well, is less than a target, then now we just want to take maybe we do like nodes is equal to get tree of target, right? So is that even, no, this would be the extra nodes, so maybe tree yeah, and then now we can I'm trying to like try to formulate a good way of doing it, because then now we can maybe like return tree and root or something like this, right? After destroying it. But I don't even know if that's like a good way of doing it. This is like a very annoying problem for sure. I don't know if that is that hard. Maybe it is. I mean, keep on saying it's not that hard, but then I'm struggling, right? So it's just annoying. I'm just trying to even nail down like how to abstract it in a good way, right? Because else, then now tree nodes that get tree, and I forgot anyway. So like root dot left, now root dot right, and then target right. And now we can return root tree or something like this. But now we want to, you know, we want something like add nodes. Just so annoying to do. Right. Basically, we want to do like an add nodes to tree, so that the root has these nodes that we removed from, but yeah, I don't know. And now maybe we could do without left is equal to none, right? And then now we could do like right node something like this. And you have to be careful, right? Because it's not just on the first level necessarily. I mean, I think only the first level or the 0th level, the top level, matters in terms of how you return and determine the tree, but the split does not have to be on the first level, right? Because for example here you can imagine that 3 is the child of 4 instead of the 2, and then you have like a 2 and a 1, and in that case you would keep, you know, recursively kind of go for this is a very annoying one, at least for me, because I'm trying to like go asleep. Okay, are they the same? So let's say we're going to the left. That means that we're trying to find the first root node that is target or less. But if we're going to the right, then no, this is wrong. I think I got the logic backwards. If the root value is, yeah, no, here, then we go to the left, trying to find the left, the first node that is to the left, and then return all the things, right? Right. I don't have enough thinking power for this. But yeah, and then in the other case of if it's less than, then you go to the right to get the first node that is bigger. Yeah, okay. Let's just call it that for now. I mean, you could probably like do some abstraction with whatever, but I don't know. Like you could do abstraction between these two, but that's a premature optimization, so I'm not going to do it quite yet. Probably not going to do it if I get it right, but definitely not quite yet, even if I am. Okay, so then now the thing I'm trying to think about is an invariant that allows me to do things a little bit easier. And here, if we're trying to get the root node that's bigger, so then if node.value is greater than target, then we want to keep going to the left. And so then now we do return node dot left, right target. But I don't want to do it recursively, but that's the idea, right? So while this is true, node is equal to. But then I already did this thing, so I think that's a little bit awkward. Yeah, maybe we don't need to do this. Maybe I don't need this. Maybe I just need to kind of. I think for one case first, and then we'll maybe generalize it later. Maybe we won't. But yeah, okay. So then now, node is not none, and this. If it goes all the way to the left, then it means that yeah, the tree is going to be just none, right? So if node is none, then return none. Otherwise, the node is the root, and that is fine. So then now we can return node because this is the first thing, right? So we don't. Let's not do this. But then that means that everything to the right side of this node is not good. Is that always true? I'm trying to think whether like we have to do something recursive or is it just true? Because then now maybe we can do something like node dot right. So everything to the node dot right, we should point at the parent, right? So maybe something like this, right? So parent is equal to node, and then node dot left we update it. Okay. So then now if node is none, we return none. If then now we just want to do something like parent dot left is equal to node dot right, and then we can return node. Maybe that's not that bad. Maybe I kind of over traumatized the thing. All right. I mean, I know this isn't quite complete because I didn't do half the problem, but I just want to see if this gets me right in the right idea. Okay. Oh, okay, yeah. Because now node dot right is none. Okay, so now we fix this one, and okay, so maybe it's not that bad. Maybe I just kind of keep on talking it through for no reason. Okay. Yeah, no, I mean, I was trying for a second. I was trying to, for a second, I was trying to figure out if I can generalize this. We can do a compare function here, but I think on the left and on the right is like a little bit awkward, and I don't know. It's fine. We'll just write it out this way. It's a little bit copy and pasty, but. Just want to keep on going to the right to find the root. I think the hard part about this one is figuring out the invariants and just confirming that that is true. And I think for me, I just struggled a lot with it. I don't know. I think maybe I was just being a little bit lazy in terms of tell me why. I mean, I know that this is because it has one node, so maybe it does something funky. So node dot right is. Oh, it's just that I'm dumb. A very specific one. All right, let's give a YOLO submit. Hopefully I'm. Oh no. Okay, well, it is what it is. Let's take a look at this one. So this is the tree. This is with 6. So then, oh, I did miss a case. I mean, this is kind of what I feared, but I just thought maybe I was misunderstanding something. Okay, so yeah, so then 6, but then the 5 and the 3 has to be handled, but we just thought that 5 would be the thing. This is so annoying to do. Because I just thought it would be 5, and then everything to the right of 5 is going to be thing, but then there is a 6 and a 7. So my invariant was wrong, and that's why we got the wrong answer. I mean, this is a good case to kind of debug around. It's going to be murder though. Okay, so then now we find the root. So okay, note that right is equal to none. I'm trying to see if I can recursively generalize this from 9, 8, and 6 and 7. In that case, we just kind of do you get the tree that is smaller? I don't know. I mean, other than doing it painstakingly, I don't know that I have a good like clean solution to it. Because then now, so okay, so let's say we're trying to do something recursive, right? So then now we have the 5. We return the 5 as the other tree. Okay, fine, right? And now we go to the right, and I just previously assumed that everything to the right would be bigger than target, which is definitely not true. I just kind of, I don't know, just not true, as you can see here. But how do I? So we know that no, that's not even true. I was gonna say the root node is gonna be greater than, but so we want to do something like node.right is equal to how do I'm trying to figure out a way to do it like recursively, but so, okay, so then now we do a get right. Okay, parent sub left is going, so the parent now looks like 10, 9, 8 thing, and we have a 5 and 3 on the other one. It's kind of hard. Okay, so 10, but we want to. Okay, so connecting this is right, but then now we want to probably process our order. Like, can I do something like get tree bigger, no dot right? Okay, right. What does that look like? Oops. Node. Is that what I want? But your target is just target. But I'm just trying to see what that would look like for this one. I was hoping it would. I wonder what this returns, but node dot right. So then it just keeps on. So then finds the next node. It should find the next node. node is not the parent. I think no, this one should be. This one should be parent. I'm struggling with the recursion. Okay. What is this node again? Maybe I'm just debugging the wrong thing anyway. So no, it's bigger, so then it should be on this side. Okay. So then now, okay. Let's just say it's okay. So the this one, it should give me 9, but the 9 is because of this returning nothing. Or like somehow we killed the yeah. So okay, so goes to the right, it is not less number. So node, okay, node to the right. I'm just trying to look at this tree again. But it's just like so buggy. Okay. So then we go to the right, we have the 9, right? I think I'm trying to be too clever. I think that is the big issue. With this regression thing, like I think I could probably just done a better filter thing. Yeah, okay. I think I'm just trying to be too clever with this problem, which happens sometimes with all this thing. I think what I want to do is a reset. Yeah, I think I want to reset. Okay. I mean, sometimes you just have to learn to accept this. But okay, so then now here, I think what I want is to set up a parent. Yeah, okay. Let's just set traverse node, right? Parent, right? If node is none, we return. Otherwise, parents of node is equal to parent maybe, and then traverse node dot left, node traverse node dot right, node right, and then now we just write it for root none. That's fine. Okay, and then now actually we should also take account target. So then I'm gonna call it the left tree and the right tree. Why not? So maybe is or smaller is equal to boolean. I guess this is a flexible thing, but how do I want to write it? I think the thing that I probably could have done is that also n is 50, and I was trying to do something like linear-ish. I think that was probably the mistake, but that's fine. Here like that. Then now if no dot value is less than or equal to target, then smaller of no dot value is equal to actually just this conditional. Let's just do it this way, right? Okay, so then now we have this. What can we do with it? We can say if smaller of not that value actually, because I think it could be duplicate. That's the thing that I took a look at as well. And then now if smaller of root, then we want something like how do I want to write it? Okay, let's just do now the first thing has to be different just because of the way that is constructed. So then now, no, maybe not, I don't know. So then maybe now we can like return filter tree of root target, something like that, and then I can just do something like no target, right? Basically the okay, I think I get it, kind of. Okay, yeah. So so I want to say smaller and bigger, maybe. Technically it's larger, I think, but fine, let's just go change it. And here we have none, right? We're just trying to establish the roots. Might need to do the parents. They're not the roots, they're just the smaller is. So I'm not explaining that much. I'm still trying to work it out to even make it work. But smaller is the last parent with smaller, right? So okay. Maybe this is not. Yeah, maybe I. I just say we filter the tree. Do we always add to the left of the node? I think so. I think that is an invariant, actually. So then I think I try to make this function do too much. I need two functions. Well, or maybe just, you know. Yeah, okay, fine. Yeah. I mean, also shadowing. But okay, so let's just go back to what I was trying to write anyway. So then now we have two trees. We want to. Okay, so then now we do some filter tree thing of the root, the target. How do I even get the other root node? I guess the function that I wrote before would have gotten the other root node, but I'm trying to do it in the cleanest way. I guess in this traverse, actually, I should be able to find it. If we do it in order, then the first node that we hit. No, it's not in order, it is pre-order. If we do in pre-order, then the first node that we hit will be the whatever, right? Okay, so Okay, small root is equal to none. Okay, that makes sense. Large root is equal to none, and then now the node and small root is none. Okay, I need to call this non-local. Okay. Okay, and then now we can do a filter tree on target, maybe small root, large root. Does that even make sense? No, not really. All right, let's see if this does anything for now. 1 and 0, that's good. We have the 5. Okay, we have the 5 and the 10, so that's good. We just have to filter up 2 and the 4. Okay, so at least that part maybe is true. Okay, so then now we want to say we don't want the smallest part of the, that's the thing, right? We want to get the next pointer I think this is still kind of this, which is very awkward. But small, large, say, and then now what we want, we also want a parent. I was trying to. Okay, so then now, if parent is not none, or if parent is none, we just kind of ignore it. Okay, if the parent is not none, if smaller of node is not equal to smaller of parent, then parent has to then what happens? Then now then we have to cut off the parent to now, which is also kind of very awkward. There's no easy way to do it, I guess. That's what I want to do. Maybe there's a cleaner way to write it, but for now I'm just going to leave that here. So okay, so if it's not the same, then we cut it off, but we also want to do smaller, or sorry, small. Okay, if small is not none, then small dot right is equal to node, and small is equal to node. That's not true. I mean, that is true, but only if smaller of node. If I don't know if I got this backwards. That's why I'm trying to pause. If it's the same, it's fine. So then now we just filter node.left, node, target, small, large, and then we also do it to the right side. Something like this. Is node none? Oh, right. Oh, okay. I mean, at least we're making some progress. We just lost the 3 and the 6, which is not great. And we also lost a bunch here. But we got the 6 back. Why is the 9? We lost the 9, 8, and 7 even. I'm gonna drink a little bit of water, hang on. Just struggling with this one a bit. I think we're close though. Don't know what happened to this one. I guess it's just this. What happened to the 3 and the 6? No, the 6 is here. We lost the 3 though. How did I lose the 3? How did I turn this off? Oh. So if filters to the left, it should be that. So the 3 should go through this, right? Disconnect the 2 from the 3, which is how we lose it, but that's fine. But then we want okay. Maybe we have to figure out this part. That value, small, that value, oh, well, small and large. It's gonna print something a little bit weird, but okay. So 2, there's no small or large. I think that's the thing, because 3, the small is the 2, but it really should have the 4. No, but the 2 differing from the 4 means that 2 differing from the 4 means that we wanted. Is that true? Okay, so if 2 is less than 4, then we want future node to use this as the thing to add on. Maybe that part is fine, but we also want to do the 4 part. Like, no, does that even make sense? 2 and 3, so then the 3 will have the 2 and, oh, whoops, this is definitely not right. I meant parent. The small, that's what. But it feels a little hacky, so that's why I'm like not confident. But I am nothing but lazy, so I will submit and see what wrong answer I get. Okay, That actually worked out well. I mean, I don't know how I feel about this problem. Definitely 40 minutes is a struggle. Not going to bed early today, but and this is all linear time, linear space. Well, not yeah, only because I want to keep the parents and also to keep track of it, whether. I guess this one it doesn't really need to be a thing, but the parents. Maybe you also don't need to do a parents because I think you can just pass that on. So maybe you could do you could get rid of these things, but it's still linear space because it's just the nature of recursion, or of H space if you want to say that's slightly better. But yeah, that's a tough invariant to code. And I was trying to do it in a cleaner way. I don't think I can. But the idea here is that for every node that is not the same, let's just say conditional with the parent, then that's when you separate them off. And then you keep track of the last thing that you separate them off from, which is how I got this thing. And then put it here. Because if small is none, then we haven't seen any separation in this tree depth. Because the idea here is that basically this kind of gave me a little bit of a hint or thing that they force us to do anyway, which is that if C has the P in the children C with a P in this original tree will only stay the same if and only if they're both the same condition, right? So I think that's the big thing that kind of it's not really a hint, but it is the idea that I kind of build off. It took me a while to get this one. I don't know what to say about this. It's just a lot of keeping track of things, and maybe I think a little bit of a retro on this one is that I'm slow on this one because I was a little bit stubborn. I think I should have had my paper ready and kind of write out the cases for this one instead of doing it in my head, because doing my head is not that fast anymore, and that's why it's slow. But yeah, let's take a look at the hint. I'm curious. Use recursion. If root is greater than you split the right into two halves. I was trying to base off this idea, but I really couldn't do it. I don't know. Let's see. Recursive traversal. Man, the way that they wrote it is way cleaner than whatever I did for sure. But these conditions are so hard to think through, at least for me. Root is no, return to root. Recursively, wow, just recursively split the left tree. Yeah, I guess so. Maybe I didn't think about this in a good way. I definitely yeah, I think in a way this is what I was trying to do, but it like the split line thing is kind of the idea about like I mean I talked about it in terms of parents, but we do keep track of the last thing, and that's basically how I did it, iterating through the loops. But yeah, I mean they did it iteratively so that they don't look at every node. I think I just kind of gave up on that idea and try to do it on every node, just because I didn't want to figure out how to special case it. But mine just doesn't do anything if parents if this is equal, then it just doesn't do anything, right? And it won't do anything for the entire subtree. Just kind of iterate through it. So in a way that kind of happens. Maybe you could say actually I'm just curious, like how. Yeah, I guess yeah. I mean, you could add. I mean, I think the way that I would do this more faithfully, and I was just like I knew that this would at worst do more work, but it wouldn't be wrong. But I think to kind of mimic this more directly, just have to add a few if statements. So I don't think this is that bad. Like Yeah, I don't. I mean, I think it's just adding some if statements so that you don't go to that side of the tree, and that's pretty much it. So that's basically my idea. But definitely the way that I did it was a struggle. Um, yeah, and you have to kind of be very careful about how to do all these things, and that's kind of why. But yeah, apparently I don't know. Maybe I'm just not good at recursion, and definitely not today. Um, That's all I have for today. I mean, maybe this is a good example of how. Oh man, I forgot to stand up, and now my watch is yelling me. But yeah, it happens to the best of us, and today I just didn't have it think about it this way. But yeah, that's all I have. Thanks for watching. Stay good, stay healthy to your mental health. I'll see y'all later. Take care. Bye bye.